Hi, welcome to a video on matrix multiplication. Yes, in the last video we talked about scalar multiplication, meaning just multiplying a variable into a matrix and adding and subtracting. And now we're going to do multiplying two or three matrices together, and so we're going to look at that a little bit today. This is a crazy picture that I found online, but it sort of explains here the idea. So, when I have two matrices, A and B, you multiply them to be A times B, and you end up with an answer. You'll notice that we couldn't add or subtract these. We talked the other day about adding and subtracting them together. We can't do that because they don't have the same dimensions, so we're going to have to look at what kind of dimensions do I need in order to multiply them together. So you'll notice here that this has 2 rows and 3 columns, so we know this is a 2 by 3. And this one has 3 rows and 2 columns, so this one's a 3 by 2. So they're not the same, but they are related, so we're going to look at that. So these are already made up, so I'm going to follow these directions. Use a red pencil. If you don't have a red pencil with you, that's okay. It's going to talk about 4 different colors. But using different colors may help at first, so if you have 4 different pens or pencils, that may be good. So use a red pencil to mark the first row of A and the first column of B. So here, my first row is 4, negative 2, 3. My first column is 1, 3, negative 0. Are they the same length? Yeah, right? 3 and 3. And so that's what's key. They have to be the same length when you multiply. You must have the same number of elements, okay? So the whole matrices don't have to be the same, but the amount of elements do. Alright, so we have that. Okay, so they did this for you here, and this is sort of how the rest of these are going to follow. You can multiply the first row of A by the first column of B as follows. So basically you multiply the elements. We already said this was 3, this was 3. So 4 times 1 here, and then you add it with the next pair of elements. Negative 2 times negative 3 plus 3 times 3 times 0, and I do the computations. The answer will be the first entry up here, okay, because we're multiplying first row by first column. So I do the computations, meaning I add the sum, and then I write it in here. So 4 times 1 is 4. Negative 2 times negative 3 is plus 6. 3 times 0 is plus 0. So there I get 10. So my answer here, my element is 10. Okay, and it follows like that. So next, mark the first row of A and the second row of B with a blue pencil and find the product. Same thing we just did. Write it in with a blue pencil in the first row and second column of the product matrix. Okay? So I have my blue pencil now. It says first row of A and second column of B. So I'm using the same row, 4, negative 2, and 3, but this time I want the second column. Okay, so again, I'm multiplying row times columns. We just did 1, 1. Now we're doing 1 and second column. So again, we multiply element by element. 4 times 5. Add them together. Negative 2 times 2. Add them together. 3 times negative 4. Okay, so here this gives me 20 plus negative 4 plus negative 12. Combine those, this gives me 16 plus negative 12 is 4. And that's my answer here, which is first row, second column, because that's what I'm multiplying. So now over here we just got a 10. And here we have 4. Okay. On to the next one. Now we have the second row we're going to be using. Okay, so again, we found out that this was 10, this was 4, now it says to use green. So I'm going to move on to the second row and the first column of B. So here, second row of A, right? Here's our second row and first column, and I'm going to do this the same thing we did in the first column. Second row, first column, and then second row, second column. So 0 times 1, add them together. 1 times negative 3 add them together. Negative 1 times 0, do the sum. 0 times 1 is just 0, 1 times negative 3 is minus 3, negative 1 times 0 is 0, and so my answer here is negative 3. I can add that into my AB multiplication matrix, product matrix. Okay, so now we have the second row and the second column, and that's going to fill in our box here. So again, we have 10, 4, and negative 3. That I can fill in, and now we have our 1 in yellow. Okay, so I'll mark the second row of A and the second column of B with a yellow pencil. So here again, second row, second column, and I do the same thing. 0 times 5. Add them together. 1 times 2. Add them together. Negative 1 times negative 4. Okay, here's 0 times 5, 0, plus 2, plus 4, and so my answer is 6. And that is your solution matrix. Let's see what the next one is. Alright, so essentially this is our answer here. AB equals 10, negative 3, 4, and 6. And that's our solution when you multiply them together. Okay, so it may be helpful to redo this problem on your own, re-multiply, look at what the red means and the blue means and what things you multiply in what order. Okay, pause, rewind, etc. Alright, that's just the same thing. So we talked before in the last about dimensions at the beginning there. So I'm going to use a red pencil to mark the first row of C and the first column of D. So here's the first row. If I want to multiply them together, first column, are they the same length? Well, no, right? This one has 2 and this one has 3. So this is no. Do you think the product of CD is defined? Meaning, can I multiply if they have different lengths here? This one's 2, this one's 3. So this one's no. The product is undefined. Okay? And so what we're going to look at is when can you and can't you multiply? Alright, so this is the rule. The product of two matrices A and B is defined only if the number of columns is equal to the number of rows in B. If A is an M by N matrix and B is an N by P matrix, then the product is M times P. Okay, so let's drag this down here. A is M by N and B is N by P, right? And so you'll notice that what has to be true is this, which is the initial columns and rows of the two matrices has to be the same. And when you write these out, it's going to be the 2 in the middle. And so your answer ends up being these two crossed out, and your answer is going to be a matrix that's this first element by this last, M times P. Okay? So a few examples here. State whether the product AB is defined. If so, give the dimension. So number 1, can I multiply these two matrices? My dimensions here are 2 times 3 and 3 times 4. Well, yes, these two are the same, 3 and 3, and so my dimensions of them multiplied is 2 times 4. Okay, how about number 2? 3 times 1 and a 2 times 3. Well, they have these two, 3 and 3 are the same, but these ones on the inside are not. Okay, those aren't equal, so this one is undefined. I can't multiply that. Number 3, 4 times 3, 4 times 4. Again, these two on the outside are the same, but these aren't equal, so this again is undefined. Okay, I'm just going to write an equal if these are the same so that you can see. And then number 4, 1 times 5, 5 times 2, these are the same, they're equal, so my solution matrix is a 1 by 2. Okay, and notice that if you switched this around, right, what if I did B times A? Now I have 3 times 4 times 2 times 3. Well, if you switch the order, you can't multiply this anymore, right? These aren't the same, so this case would be undefined. But in this one, if I have 2 times 3, times a 3 times 1, well, now these are equal, and so this now would be a 2 by 1 matrix and defined. So the order that it's in does matter. Okay. Alright, so say we have these two matrices. Find A times B. If A equals -2, 2, 0, B, 4, 3, -3, 1. Again, first thing I need to check for is dimension. So this one we know has 3 rows and 1 column. So this is a 3 by 1. This one has 1 row and 4 columns. This one's a 1 by 4. Well, look at that. These two are the same, so we can multiply here. And my answer, AB, will be a 3 by 4 matrix. Which, if you want to make this less confusing, you can start out by writing, okay, I know I'm going to have 1, 2, 3 rows and 1, 2, 3, 4 columns. So that you know you have to fill in these spaces. Okay? So, now we go through and we multiply. So, again, first row, first row, that's this way, left and right, and first column. These only have one row or column, and so we're not going to be adding things together like in the first example, but go back and look at that first example for your CPP problems and what we do tomorrow in class. So this has first row by first column, and so since there's only one element here, I'm not going to add anything together. I just have 2 times 4, which is 8. First row, second column, 2 times 3, which is 6. First row, third column, 2 times -3, which is -6. And notice I'm moving to the right just as I'm moving to the right in this matrix. And then first row, fourth column is 2 times 1, which is 2. Okay? So use a different color. Now I'm onto my second row. So -2 times 4 is -8. -2 times 3 is -6. -2 times -3 is 6. -2 times 1 is -2. Okay? And then last, let's do some pink here. 0. Oh, this is going to be easy. What happens if I multiply in 0? If I multiply 0 by all of these, I'm going to end up with zeros, aren't I? Which means that this whole third row is going to be full of zeros. And so my answer for AB is 8, 6, -6, 2, -8, -6, 6, -2, 0, 0, 0, 0. Okay? Alright, so that's pretty much it. Again, go back and re-look through the first example if you're confused about when you have to add. Here we didn't have to add because there was only one column. And here, let's switch this up. Make it 4 dice, roll. Alright, add these up in order to get the sum and answer one of your CPP problems. Alright, good luck. Let me know if you have questions.